Welcome to Ask and Learn.
We want to first graph the function f of x is equal to x times e to the 1 over x. Then we want to use L'Hopital's rule to explain the behavior as x approaches 0. We also want to estimate the minimum value and intervals of concavity. Then we want to use calculus to find those values exactly. So I went ahead and already graphed this function here. And so now looking at the graph, you can see that to the right and to the left of 0, we approach different values, because to the right of 0 it looks like it's going to positive infinity, and to the left of 0 it looks like it's approaching 0. So for part B, we're going to need to do two limits, one from the left and one from the right. So let's just go ahead and do that. So the limit as x approaches, so let me go ahead and do part B. So limit as x approaches 0 from the right. So if we have x times e to the 1 over x, if we were to go ahead and just plug in 0, well, from the right, 0, or x goes to 0, and then 1 over x would go to positive infinity, and e to the positive infinity is going to go to infinity. So let's go ahead and rewrite this as the limit as x approaches 0 from the right of e to the 1 over x over 1 over x. So now if we were to go ahead and apply the limit, the numerator goes to infinity and our denominator goes to infinity. So this is in a form of which we can apply L'Hopital's rule. So let's go ahead and do that. So this is going to be equal by L'Hopital's to the limit as x approaches 0 from the right of, so to take the derivative of e to the 1 over x, we're going to use chain rule. So we take the derivative of the outside, which will not change, and then we're going to have the derivative with respect to x of 1 over x. And you might notice that we also have the derivative of 1 over x in our denominator. So just because I'm lazy, I'm going to go ahead and cancel those out as opposed to taking the derivative of them. And doing that will leave us with the limit as x approaches 0 from the right of e to the 1 over x. And now that's going to be e to something approaching infinity, so this will diverge to positive infinity. Now, for the next step, for the limit as this approaches from the right, we can apply the same logic again, and we're going to have the limit as x approaches 0 from the left. And so actually, let's first go ahead and see what we get when we do this. So the limit as x approaches 0 from the left is going to go to 0, and the limit as so first the limit of 1 over x is going to go to negative infinity, so that diverges, but then e to the negative infinity approaches 0. So I actually have 0 times 0, so it goes to 0. So the only thing we actually needed to use L'Hopital's for was the first part of the question. All right. Now for part C, we want to find our minimum. So I can only assume in this they meant a local minimum as opposed to a true minimum, since to the left this function goes to negative infinity. And so when I looked at my graphing calculator, it looked like the minimum occurred at 1 for our x value and 2.718 for our y value. And now let's go ahead and look at our intervals of concavity. So it looks like to the left of 0, the function is just concave down, and to the right of 0, the function is concave up. So concave down Well, that just looks like it's going to be from negative infinity to 0. And for concave up, that looks like 0 to infinity. So maybe we chose some good intervals here, or maybe we should have zoomed out a little bit more. So now we actually want to use calculus to find this actually. So let's go ahead and check it out. So f of x, again, was x times e to the 1 over x. To take the derivative of this, we're going to need to use product rule. So we leave the first one the same, take the derivative of the second, and then we add them in the opposite order. So e to the 1 over x times the derivative of x. So first, the derivative of x is just going to be 1. And then to take the derivative of e to the 1 over x, well, we already did that. On the first problem, we said it was going to be e to the 1 over x times the derivative of 1 over x, which should be negative 1 over x squared. So we can go ahead and simplify this now. So these x's in the first, and let me put parentheses around that, will cancel out, or simplify to e to the 1 over x plus e to the 1 over x plus 1. So I'm going to factor, not plus 1, times 1. Now I'm going to go ahead and factor out the e to the 1 over x, and then just kind of rearrange it to be 1 over 1 minus x. So we know this here will always be strictly larger than 0. So if we want f prime of x, or f double prime of x, oops, yeah, so this should be f. Oh no, we're looking for the first derivative right now. I'm getting ahead of myself. All right. So to find that minimum, we want to set this equal to 0. Now, just like I was saying though, this here should always be strictly greater than 0. So we just set 1 minus 1 over x equal to 0. And doing that, we will get 1 minus 1 over x equal to 0. Add the 1 over x over. We'll get 1 is equal to 1 over x. Reciprocate each side. And that tells me 1 is just equal to x. So at least the x value we got before was the same. And now we can go ahead and plug that in to see what our minimum value should be. And so that is going to be 1 e to the 1 over 1, which just ends up being e, and that is approximately 2.718. So that one checks out. Now let's go ahead and look for our intervals of concavity. So we had f prime of x is equal to e to the 1 over x, 1 minus 1 over x. All right, now when we take the second derivative, we're going to have to use product rule once again. So it's going to be e to the 1 over x times the derivative with respect to x of 1 minus 1 over x. And then plus them in the opposite order, so 1 minus 1 over x times the derivative of e to the 1 over x. So derivative of 1 is 0, derivative of negative 1 over x will be 1 over x squared. And again, the derivative of e to the 1 over x is going to be e to the 1 over x times negative 1 over x squared. So it's going to be over x squared plus 1 minus 1 over x times e to the 1 over x minus 1 over x squared. And now let's go ahead and factor out this e to the 1 over x. Oh, this should be multiplied, as well as the 1 over x squared. So it should be e to the 1 over x over x squared. So the first part will become 1, and then plus 1 minus 1 over x. And I forgot to distribute this negative right here. So distributing that negative inside here would actually switch these signs. All right, glad I caught that. All right, now the 1's cancel out, and we're just left with e to the 1 over x over x squared times 1 over x, or better yet, we can write that as x cubed. Now, again, like I was saying in that last part, our numerator here will always be greater than or equal to 0. So wherever our denominator will be negative and positive will decide our interval. So to the left of 0, x cubed is negative, and to the right of 0, x cubed is positive. So we just get f double prime of x is, so concave up on 0 to infinity. And remember, this is when f double prime is strictly larger than 0. And we're going to have that the function is concave down on negative infinity to 0, which is when f double prime is strictly less than 0. So it looks like our graph this time really did give us all the information we really needed for this, and we really didn't need to estimate it or use calculus to really get exact values.